Hi, in this video, we want to take a look at comparing capital gains between different securities, and we're going to be using R. Okay, so the situation is that I have multiple stocks I'm interested in, and I want to see how they're doing and how they're performing, but also want to compare them in my analysis. Well, now, if you think about like Amazon stock, that's pretty big. Those prices are pretty big. And if I'm simultaneously looking at Amazon and another stock that has a much lower prices, then I'm going to have a problem when I try to visualize it, when I try to interpret things. So the magnitude of my largest values is going to drown out my analysis of the others if I try to look at them at the same time. Okay, so what we're going to do, we're going to normalize all of the stocks I'm interested in by a particular date, and that way I can compare to see how they're doing. What's going to end up happening is that the time series plots that we look at will have the same shape, the same presentation, but they're going to look different in terms of the numbers. The numbers will be different because it will be the numbers I look at are relative to the baseline day. All right, so now this code is modified from Clifford Eng's book, Analyzing Financial Data and Implementing Financial Models Using R. So here is the Amazon link. Here is Springer. It's a Springer book. All right, so when I'm looking at capital gains, we're looking at the difference between a baseline day and today. Now, when I normalize, instead of doing subtraction, I'm doing division. Okay, so what that does is if I see, let's say 1.5 on normalized, I know that that's a 50% increase. And if I see 1.1, I know that's a 10% increase compared to the baseline day. And so this gives me a standardized way in relation to the number one to figure out what's going on. All right, so let's go ahead and load our ticker data. Oh, something I'm going to do, I'm going to suppress some numbers, and this is typical for what I do, is I'm going to set the number of printed digits to 2, just so that we don't get blasted in the face with numbers when we look at it. All right, so in my code, I'm going to set my first date. All right, so this is going to be my baseline date, and then I'm using batch get symbols to grab the data. So, all right, so we'll look at Amazon, Alphabet, Apple, and it's the SP500. Okay, so first date is, of course, the first date. Today's date is the last one we're going to get. The threshold for bad data, this is checking to see if there's bad data, don't accept it. How bad does it need to be before it doesn't accept? This determines what our market is for where we're getting the data. So the default is SP500 US market. And we're going to return the data for arithmetic instead of log. We have options of arithmetic or logarithms. And then I'm going to go ahead and grab the frequency of daily. I could also do weekly or monthly or yearly. Now, the batch get symbols output is actually a list of 2 items. First one is like how things performed. Were things successful when I pulled the data? All right, if everything's going well, I don't care about that. So I'm just grabbing the second part, which is called df.tickers. All right, and here's the feedback that we get on if things are going well or if there's a problem. So everything worked out this way. And so here's what our data looks like. And so we're interested in the closing price of our data. So here's the first 6 rows. Here's the last 6 rows. And you'll notice that it pulled the data in the order that I gave the tickers. So I put in Amazon, Alphabet, Apple, then SPY. And so then it goes exactly in that same order. Amazon, Alphabet, then Apple, then SPY. All right, let's go ahead and visualize the data. So let's do a quick, easy ggplot. And so I'm doing using a ggplot function. And I'm saying that the date is the x-axis, the closing price is on the y-axis, and I'm coloring by the ticker. And then I'm drawing the time series plot, and I'm breaking it up by the ticker. Okay, and so we can see that we have nice time series going on, and we can see what's going on for each individual stock. Now, check out the numbers that we have. Look at Amazon and look at SPY on the y-axis. On the y-axis, I can see that everything's in the thousands here. For SPY, everything's in the hundreds. Okay, this is going to come up in a moment again. All right, so now what I'm going to do, I'm going to try to put everything into one plot. That way it's easier for me to compare what's going on. If it's easier for me to compare what's going on, I can get a better feel of how I should make changes to my portfolio. All right, and everything's the same except for I'm not doing the faucet wrap. I'm putting everything into the same plot, and here I'm adding a title, which we'll see in a moment. All right, so what happens here, you notice that Apple and SPY, that they just look flat. I can't see what's going on. I know stuff is going on here, but for the most part, things are pretty flat. Why is that? Well, the Amazon values are so big that this part is squeezing out the rest. And since it's squeezing out the rest of it is getting muted. I can't tell the difference. All right, so what we're going to do, we're going to normalize each of these 4 time series, and then we're going to, that way it's easier for me to judge what's going on with each of them. All right, so now what I need to do, I need to go through, I need to normalize the data. So what I'm going to do, I'm going to take that data frame I have, I'm going to break it up into sub data sets for each ticker. All right, so I'm going to use the split function. I'm going to say, hey, take this data set, break it up by the ticker column. So X is the data set, F is the factor for breaking it up. Now I'm going to create a list of the normalized data. Now what I'm going to do, I'm going to grab the data. So here this list data is an object that has the Amazon data, has the Alphabet data, has the Apple data, and it has the SPY data in 4 separate places. I'm going to go across each of those 4. I'm going to grab the part I want. I want the sub data frame that I want, and then I'm going to work with that. So I'm going to grab, for each of them, I'm going to grab the sub data set, and I'm only going to grab the columns I want just to make things faster and more efficient. So for this analysis, I want the date, I want the ticker, and I want the closing price. And now something I'm going to do, in case there was an error in loading the data, if there was a problem in loading my data, if something was lost, what I'm going to do, I'm going to get rid of cases where I have missing values. This is what the NA omit does. For the example I'm running, for right now, as I'm sitting at the computer, I didn't need to do this. But if you're going to run this and you start using different, maybe different sources for your ticker data, maybe different tickers, you might have missing values. So just to make sure that we have quality assurance, I put an NA omit in there. Now what I'm going to do, I'm going to find the earliest date. So I'm using which.min, and I'm going to find the closing price on the earliest date, and then I divide the closing price by that initial date. Okay, so what's going on is in this normalization, the earliest date that the closing price is in the data, that's going to be a 1 in this normalized data set. And that's going to be like my baseline as I judge everything else. And then I store this new normalized data in list normalized. And then I use the dplyr package to basically take all those normalized assets and just put them together into one larger data set. So now let's go ahead and plot it and take a look at what's going on. And so once again, I'm using ggplot. It's the same plot as we saw before, but I've changed the data. Instead of using the raw data, the original closing prices, I'm using the normalized closing prices. And so here's my time series plot of the normalized data. My closing prices are normalized by January 1st, 2015. Now, if that's not actually in the data set, which I don't think it is actually, what's going to happen is I took the earliest one available. So it's going to be the next day that the market was open. And so here, this is a vertical value of 1, and we can see relatively how much each of these have grown. So we can see that in this presentation, Apple proportionately has grown more than Google, or so Alphabet, which I didn't expect. That surprises me. Also, I thought the SPY would actually have been proportionally bigger. I thought Amazon would be proportionally smaller. I'm surprised by this. All right, so I hope you like this. This gives us a way of comparing stocks without making the largest one drown out the other information. That's all I've got for you. Take care and goodbye.